Good afternoon, everyone, and thank you for joining us again for this Passivhaus Retrofit webinar series. In this session, I'm absolutely delighted to be joined by Carl Goodhew from G2 Construction and Consultancy. What Carl is going to be doing is sharing the, taking you through the project and talking through the whole build process. What that means is for this session, we're actually inviting a small number of questions after each build stage so that Carl is able to answer any burning questions that you might have before we move on to the next section. So thank you again, Carl. I will stop sharing now and allow you to share your presentation. Thank you.
Thank you, everyone. So my name's Carl Goodhew. I am the founder for G2 Construction and Consultancy. We are a building company and we specialize in passive house, EnerPHit and low energy. We have been around for 5 years, and some of our bodies that we are accredited with are the Passive House Trust. I have the Certified Passive House Tradesperson qualification. We're members of the AECB. We are also members of the Chartered Institute of Building. So we've got a huge depth of experience and memberships and qualifications behind us to help educate people and raise awareness to the mission that we're on. I wanted to give you a bit of context into the project first, so you have a better understanding of what the project was versus what the project is. So I'm just going to bring up some drawings. So the project that we worked on for this specific retrofit is a Victorian terrace property. We believe the building was around 1905 when it was built, and it's a traditional 2 up, 2 down. On the left-hand side here, you can see the front elevation. So we have a bay window. We have two windows at the top with traditional stone lintels, and the front door has a stone lintel as well with a fan light above. On the rear, it has a lean-to extension with a mono pitch. We believe this was actually built later on from the original date, and it would have had some form of outbuilding which would have housed a toilet, but in its place now we have this lean-to building here. And to give you some context, I'm just going to bring up a sectional drawing for you here. So this is, this was the phase 1. So you can see if you cut a cake in half, you can see the insides of the house. So you can see as you come in the front door, you would have the staircase up to the first floor. So you had a bedroom, 2 bedrooms, a landing, and downstairs you've got the rear extension. And what I'm going to do is I'm going to explain the process with a portal that we use. We use a system called monday.com, and for our projects, we invite our clients to this board so they can see what we're doing and how we're doing it. The project actually started out as a phase 1, and the phase 1 was to take the original footprint of the property and to just excavate the floor and re-insulate this to an EnerPHit standard. Throughout the process of the design, our clients' family grew, and so the phases of the project grew. So it actually started as a phase 1, then went into a phase 2, which was then to have a second floor dormer. So the lean-to extension was always to remain. And then during the phase of that, they were just considering the disruption to the project and actually took on a phase 3 design, which was to do a 2-storey rear extension, adding more space to the rear of the property. So what started as a smaller project grew for us and grew for the clients, but it changed everything about the project, because the original project was only to do the ground floor slab and then to add those phases later on. So it was quite, it was a growing project and a very challenging project, because the brief changed quite significantly. But nonetheless, it was a full house retrofit, which is a challenge in itself, but ultimately doing things in one singular phase is a lot easier than doing it in singular phases over a period of time. But it also comes down to your drives, your mission, your purpose, and everyone has different family sizes. So it will always be, a project that's centered around yourselves. So what I'm going to do now is show you the stages of the construction project. So we started with the substructure nonetheless. And during this particular phase of the project, a Victorian property generally will have timber suspended floors. So these were removed in order to create the new ground bearing slab. And just to show you some of the images that we have shown. So this is within the rear extension of the ground floor, and you can see on the perimeter we have to use an XPS insulation to build up the requirements of the insulating values that we need. Around the bay window, it's the insulation values that we need to improve to a 1905 property because there will be none. They're solid masonry wall, generally around 225 deep, and they would have been made from porous materials such as lime. So we have to consider when doing a retrofit, the year that the house was originally built. Properties from the mid 1800s right up to the Second World War will all be lime materials. Anything after that, it becomes cementitious. And so you have to treat retrofits subject to the property's age. So with this one, it was very much driven by the age of the project, or the age of the property, I should say, and slightly towards our clients' beliefs as well. For this particular project, our clients were driven by using products that aren't harmful to them post-occupancy and that cause damage to the environment. So they didn't want to use any plastics. They didn't want to use any cementitious products. They didn't want to use materials such as PIR. And so that's the project was driven by their beliefs. So taking this element here, the XPS insulation board is installed to the perimeter of the property, providing the necessary U values it needs to have to bring the ground floor slab up. And as we start going through, this is when we start then installing what's called jab-like insulation. And this was around 275 mil in depth with a DPM below that. And as we start progressing through the pictures, you can see some of the perimeter insulation that we've had to install. And we've actually tapered this for a reason so that when the next layer of insulation comes down to the walls, we've got a perfectly good joint, but it's also above the concrete level. So we're always thinking about the next step ahead, which is always very important in the construction industry. It's having a partner that is always thinking a few steps ahead is always going to save you money taking on someone that doesn't have that foresight because they're not planning, they're very reactive. So with how we work, we're a very proactive company and we're always looking to make sure that every step is considered because to go back steps is going to cost money and ultimately time. And when you're creating a project such as a retrofit, you do have to follow very important steps to ensure that you achieve the primary goal. And with a retrofit or a passive house project, it's the air tightness strategy, which is a highly important part of the project. So as you can see, we've got the external XPS board, which goes around the full linear footprint of the building. And with a 1905, or I should say Victorian property, you will have features such as chimney breasts. And they're very difficult to work with because the way the brickwork was built is the chimney is linked to the neighbouring property. And so those bricks are actually passing from one structure to the next. So getting the air tightness strategy correct has to be thought out. Our clients were very insistent that they wanted to keep these features because they are, when you go back to, if you look at modern properties now, new build volume housing, they lose all these, traditional features that we would have had throughout the Victorian era, Georgian era. And so making them work within the property has to be very considered. But you do have options, and it's really dependent on the structural integrity of the building and how the project will be once you've done the work. So if you're wanting a more open plan consideration, some of these chimney breasts do act as supportive members. But what we came to realize after we had done this retrofit, we think sometimes it may be best to remove the chimney breasts if you've got the right party wall agreement, and actually put them back as a fake chimney breast, because getting the air tightness strategy whilst we made it work, it was quite time consuming, and we think we could have saved a little bit more time if they were removed fully, because they're inactive chimney breasts anyway. But in some of the pictures, you'll be able to see, if I just zoom in a little bit more, you can see on the vertical abutments to the chimney breast, we've got a tape from Seeger, which goes up the wall. And then the green board, if anyone is unaware of what that is, it's actually called a smart ply, which is an airtight board. And so those two structures coming together have to be taped. And so that's what these vertical abutments here are actually doing. So your airtightness strategy, well, easy on paper. The reality is it can be quite difficult. And as builders, we like simplicity. So it gives you an idea of what you have to do to achieve works to a ground floor Victorian property, in bringing those insulation levels up. And the reason we bring those insulation levels up on the ground floor, for those that on the call that may be from a homeowner perspective, Victorian properties are built to ensure it has a high level of ventilation. So ventilation comes underneath the timber suspended floors on the ground floor. And when you look around the facade, you'll see air bricks are scattered around on the external facade to the bedrooms, to the living room, to dining rooms. And it's about that cross ventilation. And what ventilation does is it minimizes damp. And you may have seen in some of the news stories in recent years about mold building up in people's properties. And it's down to the ventilation. There's not enough ventilation. So the damp and the condensation, you get the heat, it condensates against the window. The condensation then comes down onto the local area. And there's not enough ventilation to then disperse the condensation. And that's why you get black damp. And so when we look at a Victorian property, the floors have to be removed, because the ventilation is then actually causing a negative reaction to the newly insulated floor, or what could be a suspended floor, because you're heating the mass above, but the ventilation below is cooling it down. So it's not the best. You can overcome those problems, but with this particular scenario, it was best to just lower the floor and just bring it back up in a insulated slab. As we progress on, we start then laying down a damp-proof membrane. This protects any moisture coming up from the ground, and so it doesn't penetrate the concrete. So we have a separation layer. That's what this is. And onto the right-hand side of the black sheeting, you'll see the sand. So we build up an aggregate layer, put down a sand layer, and that stops any penetrations into the black membrane. Because the last thing we need is to lay down the black membrane and actually have any small micro holes, which actually allows moisture into the building. So as we move on to the next photo, these are just the steps as we progress, as we start coming towards the concrete slab. So this is more of the sand layer coming in. As you can see, it's fully sanded now. And then we start getting up to just ensuring all the corners meet the necessary standards that we hold ourselves to. So once all the membranes and once the membranes go down, the insulation then comes on top, which comes in the form of the jab light insulation. So this one was 275 mil. Excuse me. That goes on top of the membrane. All the insulation boards are then taped and sealed with another separation layer that goes on top. And in this particular scenario, we have underfloor heating. And again, we have a separation layer below the underfloor heating. The underfloor heating plays an important part because the house is heated by an air source heat pump. So the spacing of the loops in the underfloor heating are suited to the air source heat pump design. But with the underfloor heating really has gone in as a more belt and brace to make the heat, to produce heat in the really cold climates that we could potentially get. When you have a retrofit or a passive house standard of building, the heating is really, you don't need it because the house is so highly insulated that a small micro radiator, oil filled radiator, you could turn it on in your house for about 5 minutes and it will warm the house and it will retain that heat. So the underfloor heating really is a luxury, in all honesty, in our opinion. But people like to have that feeling, below floors. And on to the next stage, which was a liquid screed. Excuse me. So coming back to our client's preference of having non-cementitious materials, this particular the concrete we use in the foundations and in the screed are actually low carbon. So it's less harmful to clients. It's less harmful to the environment. It comes with an added cost. Unfortunately, it is more expensive, but the cost wasn't the driving factor for our clients. It was about the carbon footprint and how they could reduce that down. So this is us preparing to lay the screed. And as you can see, it's pumped in from the street. So if no one's ever seen what a screed installation is, it's made up of a big concrete cylindrical lorry that will park up in a bay outside the property or on the land, subject to the property that you've got. Then you have a pump which is behind, and then the pump brings in the product into the property, and it gives you this very, very level and seamless finish throughout the property. And this cures a lot quicker than a traditional sand and cement screed would. So with a sand and cement screed, it's generally around 1 millimeter a day. This will do 2 to 2.5 millimeters a day in curing time. So that's a saving factor over the duration of your project. So if you've got a sand and cement specification, it will take longer to cure, which stops you laying your finishing products on top. You could have a timber floor or a tile. So that could add more time to your project. So you have to weigh up the pros and cons of with a product such as it comes with a slightly higher cost, but it comes with a quicker curing period. So it's all about just weighing up those factors. So that brings me to the end of the first section. So happy to go to first set of questions if anyone has any before I move on.
So we've just had the one, and I will just stick with the one if that's okay, only just because of time, because I know we've got another 10 stages to go. But James says, "Hi, Carl, good to see you, mate." So I don't know if it's a friend. Very insightful presentation. With the 275 mm jab light floor insulation, what U value is achieved? Any issues with the foundations in digging lower for the new floor build? Up underpinning needed with the deeper dig out with the non-standard building materials to achieve passive house levels. How much percentage increase would the build be versus standard build? That is James from JL Architecture, just in case that is someone that you know. So thanks, James.
Yeah, James, hi, thank you. Very, very valid points. U values, off the top of my head, I wouldn't be able to answer that one. We're getting close to the 0.1s. PIR 0.7s, 0.8s, give or take. Regarding the sort of the excavated depths, it does have to be considered about the underpinning. In this instance, we were fortunate that we didn't have to do any underpinning. The only thing that we had to do prior to the slab was we had to have some waterproofing paint applied to the perimeter brickwork as a belt and brace, because Victorian properties are notoriously bad for foundations, as they only have a corbelled brickwork detail, which is probably 2 or 3 courses, maybe 4 at max, and then it's just built on muck effectively. So it's a very valid point. And to overcome that, the best thing to do is always undertake trial pits first, investigation works. So that would open up the ground, understand the topography. The geotechnical report would highlight if you have to do any deep foundations, trees in the local proximity. It all plays important factors in doing a retrofit and construction projects generally. So always having, I suppose the best thing to do is just to ensure that you overcome problems early on by just doing as many investigation works as possible. I hope that's answered some of your questions, but happy to answer some more as we go on. As we move on to the superstructure section, to give everyone some more context, as we started the project, we actually had phase 1 and 2, which was the dormer, and which is on the second floor. So anyone not understand what a dormer is, it's a loft conversion room in effect to either the front or the rear of the property. Generally the rear. Planning consents don't let you have a dormer at the front of a property. But yes, it's an added room where it comes out of your lofts. So we had that as phase 2. And halfway into phase 1 and 2, the client said, look, we're going with phase 3. So we started to do phase 3 on a superstructure. And for this particular project, it was a rear extension, which you can see on the back here. So I'm just going to highlight that very quickly for you. So it was this section. Oh, sorry. Oh, there we go. It was marker rectangle. It was this section here at the rear of the property. So this was a 2-story extension, and it was specified to have a Larsen truss. So with Passivhaus new builds, and in some cases retrofits like this one, a very popular method of building construction is timber frame. It's it's higher performing from an energy perspective than a traditional brick cavity and a block. And this is what in this instance was how this project went forward. Just to give you some context before we move on to the Larsen truss. So this is all the original brickwork inside, which had to be stripped back, which I'll explain more as we go on. But you can see it was a traditional London Flemish bond, and it was all made of lime plaster. So all of this had to be stripped off for some of the later stages. This was in the second floor where the existing chimney was taken down. So you can see the levels and the extent that we've had to go to get this building stripped back to what was necessary for the retrofit. So for the first and ground floor extension, this was made of a Larsen truss timber frame. This is on the first floor, so this is the added bathroom. So I'm just going to zoom in, and for anyone that does not understand what a Larsen truss is, it is effectively a timber frame construction made of 2 timber frames parallel to each other, which have supporting gussets. These plywoods in the bottom there, they support the 2 timber frames side by side to hold them together, and it's deep filled with insulation to meet the U values of the requirement of the project. And so we did this for the ground floor, which this is the first floor. You can see this first floor is sat on the ground floor construction. And as we go through, it's just a different angle. So this is the added bathroom. And inside, this is from the dormer. These are what the walls would look like when we get to an airtight perspective. So the green smart ply is applied to the inside of the Larsen truss once it's been insulated. And on the outside, in this particular instance, to make the project look like it has always been there, was actually clad with brick slips, which is effectively a brick, and it's cut down and it's glued onto the outside. And I'll be able to show you more images of that later on. So you can see in this image here, this is from inside from the previous photo. And this is us insulating the Larsen truss with a roof light into the main bathroom, giving them a first floor bathroom as that was on the original ground floor. This is on the outside, so we have to apply a wind barrier. So all the materials, we worked with a company called Seeger, who are a world-leading air tightness membrane manufacturer from Switzerland. They have a very large R&D factory in Switzerland. Switzerland or Austria, I can't remember which one it is. And this is where all of the tapes come from. And depending on your background, so if you're a homeowner, you will be tasked with using these air tapes, I should say, sorry, which have all been tested, regulated to make sure they meet the requirements of. And for an architect, if we've got any architects on here other than James, these are the products that you will have to use if this is your first time about retrofit, to making sure junctions, abutments, membranes are all adhered to achieve that air tightness strategy to meet. So for a retrofit, you could have EnerPHit, which is the Passivhaus standard, but you could also have lower standards of that, but it all has to have these tapes to meet the compliance of. So this is inside the bar, inside the dormer, sorry. So you can see the air tape membranes on the ceiling. We changed the membranes around. The green board are on the vertical abutments and the front or elevation pitch, but on the main ceiling, it was changed to Seeger, and it's all about moisture. Coming back to my previous comments about moisture in a Victorian property, we have to allow movement of moisture, and that's exactly what this Seeger Marex does. It allows it to come through and allow the construction build up to still release moisture that's in the materials, because the last thing we want to do is trap moisture, because it creates damp and it deteriorates the products. So we always have to consider how we still maintain the structure, the integrity of the structure. And so that's why you will see different products used in various areas of the construction project. Let's see if I can bring up some more pictures of the Larsen truss. No, I think we're done on that one. So as we go down, Larsen truss, same ones. So this is inside the dormer again. So we start adding a cavity barrier, which is a service barrier, which protects the air tightness boards. We're bringing it away so we can't puncture it with a screw or with a drill or any sort of tool as we're building. Coming back to the point I mentioned about the brick slips. So you can see on here, the clients were very, very leaning towards maintaining the original aesthetic of the building. So we've adhered brick slips in the same formation of a London Flemish bond. So you can, a Flemish bond, for anyone that doesn't know, is basically a half brick and then a full brick, a half brick and then a full brick. And then you have the end small one here, which is the Queen's head closer, basically, and that fills the gap in at every single end. So this is very much like a tiling job. We are literally tiling the outside of a house, but we are doing it with a brick formation. And this was all pointed to make it. So this adjacent wall is the original, and this corner here is all new bricks, and they have to be manufactured. So you don't just buy them off the shelf, unfortunately. So just zoom out. This is just the various stages of the brick slip. So this was on the dormer. We set the corners out first, and then we work back. So it's a very methodical approach in how we do it. And I think there we go. That's from the rear elevation. So to give you some more context, the dormer is on the second floor. The first floor, you've got the singular bathroom, which is pushed out from the original property. And then you can see on the ground floor, we've got the extension, which the first floor is formed on. And again, it's all brick slip. So it's meant to look like it is has been there for a very long time. It's to help the planning officers. So this is where a good architectural practice and a design team will help you get planning permission approved a lot quicker, because the planning authority is very difficult and a challenging obstacle in any construction project. So ensuring that we work towards what they want, but also what you want. There has to be a fine balance. And so we had pointed the building, which is where we apply the material inside the brick slips. And again, we have gone with, our clients have gone with traditional lime mortar. So they wanted it to look like a traditional London property. And so we had to source the best materials. This lime actually came from France, and it was applied as it would have been from the very get-go from the use of bricks. So as you can see, it looks like it has been there for a while. Obviously not the scaffolding there, but we'll be able to show some more photos of the finished product later on. There you go, a few more images of the brick slips being applied down the side passage. And that's from the ground floor extension. So you can see even the brick headers we put in as traditional bricks. It gives it a bit more feature details with triple glazed windows and doors, which I can talk about shortly. Another one of the 5 main ingredients for a retrofit or a passive house, having triple glazed windows and doors. This is on the first floor. So as you can see, it just looks absolutely stunning. We've got traditional, not quite cast iron. We've gone for an aluminium gutter in here, but it's all just to make sure that the project looks like it has always been there for a long period of time. Happy to answer any questions on the stage of the superstructure before we move on.
Yeah, so thank you. We had a question. Did you do any moisture analysis before you started work?
Yeah, good question. So that would have been carried out by the design team, and they have carried out a moisture analysis. The practice that we worked with are very, very good. And retrofit Passivhaus, it is a science. It's not just a have a go methodology. It's all based on science, and it's all about the moisture and how it transfers through certain products, how it doesn't transfer through certain products. And so it would have had a moisture test done. If correct me, I think the test is actually called a woofie calculation, and it has to be done to ensure the balance of moisture being movable through all of the products, including the brickwork, the lime, the ceilings, everything. So yes,
Yeah,
was the answer.
excellent, thank you. And just as a time check, Carl, we're about half an hour in, so I know we've only got 2 of the sections. So one quick question from Sabin: what
Yeah.
are the brick slips adhered to?
So they're adhered to a cementitious product, a cementitious board, just with a tiling product, in tiling adhesive. It's you have to be, when you're building extensions and products, that are within the boundary. It's all about building regulation and making sure that the timber frame is protected from fire. So we can't spread the fire. So you have to use a cementitious product which protects the timber. Okay, so I'm going to move on to, I'll try and speed the presentation up as best I can. I'm going to move on to the roof section, where this particular one we had, coming back to the presentation. So we've got a pitched roof at the front, and we've got a flat roof on the back, 3 flat roofs on the back, I should say. So the roof was fully removed on this particular project. We reused all the materials. So we are very much, our mindset is if we can reuse it, we will. So the front of the property was, the tiles were reused. The free roofing, flat roofs at the back were new products. And I'll just show you, because this is not a very exciting couple of images, but you can see all the tiles been reused. The vents coming through here are for your MVHR. We've got triple glazed roof lights on the top there for the new bathroom, which is inside. This is from the front elevation at the street. So this is after we had done some lead work to the boundaries, the party walls. To the rear of the property, lead work. Let's see if everyone wears through. So we've done some new lead work to the ridge, because we've got 2 roofs coming together. So it's always about looking at how that works. And as we go down into the fascia, soffits and downpipes, we painted all of the fascia, soffits and gutters with products that weren't damaging to the environment, so they're all water-based. They do take a lot more coats of paint to do because they are water-based, but nonetheless, they are a lot more healthy for the environment and for your own well-being. So the smell of oils and all that sort of thing are removed. Let's move on to the M&E first fix. So I've only got a few photos on this one, but this is more specific to the MVHR. To give a quick analysis on MVHR's mechanical ventilation heat recovery system. It is another requirement for a passive house or a retrofit. It brings in fresh air, it pushes the fresh air into the property, and it will take the stale air out of each individual room. It will put the warm air back into the property, and it will take the stale air, filter it, and push it back out into the environment. And to do that, you have to install a series of ducts throughout the property, which is a challenge for properties that have not even been remotely considered about how you install an MVHR. So it's challenging overcoming the structure. We will always say to our clients, to our design teams, to our collaborators, who we're working with, we will try to work with the structure as much as we can, but it's the inevitable that you will have to overcome those sorts of things due to change of direction. So in this instance, the two ducts, the in and the out, are going with the joist, but to then go, which are going front to back, I believe. But if you need to come left to right, you are going to overcome problems like this duct here, which comes below. So then you have to start considering drop ceilings. And so that's where we get the complexities. In the MVHR system, you'll see these rectangular ducts. They are called silencers because ductwork is noisy. We are taking fresh air in and we're distributing it around the house and taking it out. So what happens is when you get bends, you get restriction, which means you get whistling. And that's what these blocks do. They actually take the sound, dampen it down, and continue to push that noise, continue to push that fresh air and stale air throughout the property. So as you can see, we do have some challenges. We have to come along, up into the next floor, to the next floor, and so forth. And so it's really about getting on board a contractor and their supply chain and overcoming these problems earlier on rather than later on, because it's just going to cause you problems. And so the best things to do is to talk them through collaboratively and work out how you do this. And in this instance, it's creating what we would call a riser. And a riser is just a void, a space to get cables, ducts, whatever it may be, up and down throughout the house. And you can use, going back to the chimney breasts, you can use them as risers. They are great for getting ductwork up and down because that's what they were used for originally. They took smoke out of a property. So it's about clever ways about overcoming installs, because as you can see, the ducts are not small. They are 125 mil in diameter, so 2 by 2 by side. That's 250 mil. That's sort of like 8 to 10 inches of space that you have to find. So it's very important that you work with someone to overcome those problems. That is the MVHR section. Has anyone got any questions on any MVHR before I move on to the next section?
We haven't had any questions in the Q&A on MVHR yet. No, so.
Okay, so I will move on to the next section, which is the partitioning. So for this particular project, we've mentioned the age of the property being a Victorian building, which was built with lime products. And so in order to maintain the structural integrity of that building and the moisture that could still be needed to transfer between inside outside, this project had a diaphanite applied, which is an insulating lime render or lime plaster. Excuse me. So coming back to the steps that we took earlier on in the project where we removed all of the plaster, that was done so because we have to apply something called a parge coat, which aids the air tightness. So there is a reasoning behind this. We have to aid the air tightness. And so brick is very porous for air. It will let air pass through the mortar, pass through the porousness of the brick. And so the parge coat is made of lime, and we adhere that to the inside of the brickwork to create the air tightness strategy. It's sealing the air. And so that's one of the first steps to applying an air tightness strategy to a Victorian Georgian property. And as we go through the slides, you can see this is the bay window internally. It's quite a thick coat. It's around 25 to 30 mil applied. And it has to be then scratch coat. So we have to adhere an insulating board thereafter. But this was done to the original front and rear elevations because the side elevations had a different strategy. And you saw in some of my photos previously, we had the green airtight boards. That was the different strategy for the boundary walls. So we had two strategies for the brickwork, one for the front and rear and one for the side. So you can see in here, for example, we are using this is in the extension. You can see we're using the green board, and that was applied throughout the verticals and throughout the property to the party walls. And this is the line still being adhered to the first floor front elevation. All your windows and doors have to be in first again. So that is a thought process when you need to order your windows and doors ahead of time, scheduling, having a good partner on board will help you overcome those challenges. So once the parge coat has been applied, we then apply the wood fiber boards, which then go on top of the parge coat. These are adhered to the parge coat, and that's to the front elevation, the rear elevation, and that is bringing up the U values of the brickwork. So this is all about the insulating levels now. So we're trying to increase the thermal mass of the building. All of these boards are taped, sealed, jointed before the next stage. So it's a multi-layer process, and it's not a complex process, but it's a methodical process that you've got to consider. So having your correct partner builder will have the correct person on board to be able to facilitate this for you, because it forms a huge importance to the air tightness strategy. So having the right person on board to do it, or right team on board, is very important. So now we get to the lime plaster stage, which is on top of the wood fiber board. And you'll see these are the reveals to the front and rear elevations. And it's called lime green solo. It's available from some of the eco suppliers that you may be aware of, some of you homeowners. There are a few building suppliers that you can go to get test products. Unity Lime is one. We use them quite a bit. Ecological Building Supplies, I think, is where our supply got their materials from, and they're all breathable, sustainable products. So it's always worth doing a bit of homework where you get your building materials from to make sure they work with the building that you've got. The thing about lime is you have to have a curing period, and in that particular project, or on that particular scenario, we had to have a 10-day curing period. So you can't apply anything to the lime after. It has to fully dry. Otherwise, it traps moisture, and it comes back to that moisture strategy that we spoke about earlier. It's all about the next steps. Think about the next steps to make sure we don't cause any undue damage to the lime. And also you have to consider what you're going to be applying to the lime. And from that respect, I mean decorations. So we can't be using oil-based paint because it will trap moisture inside the lime and causing more damage. So you've got to have breathable paints as well. So there's multi-steps that you have to think about when you're taking on any form of construction project, and just making sure all of the cross-layer materials all comply with each other. Other areas of the project unrelated to the lime. So this is us now closing up the project from a dry lining perspective. As you can see, it's a lot of plasterboarding. And in where we've got the plasterboard, it is a traditional gypsum plaster. So gypsum plaster can be used in an air tightness strategy as well, as long as it's been considered. But in this instance, all the ceilings and all of the walls where it was timber frame boards and surface battening, it was a gypsum plasterboard, and then a plaster skim applied to that. So it's a relatively modern method of construction. So we've got a bit of a hybrid of some of the works that we've been doing here. So you can see the plasterboarding meeting the lime plastering. And I think that is about it. Just a couple of images on the plastering, which we've done throughout the project on the ground floor. So happy to answer any quick-fire questions on the last two sections.
Yeah, so did you have any air tightness, or did you have an air tightness champion on site?
The Passivhaus educate you to have an air tightness champion. What we do in our company is we have airtight champions, because if that airtight champion is ill or not on site, we have lost that airtight champion. So we make sure everyone is an airtight champion. So we have champions. So yes. Um,
Excellent. Yeah.
Next section, the air tightness test. So what will happen is you'll get to certain stages of a retrofit or a passive house, and before you go on to the next step, you have to do an air test to make sure you've got the compliance. The only photo that I've got on here, I'm afraid, is this was the third air test, and for a retrofit, if it's being certified, the air test is 1 air change an hour. I think for a new build, it's 0.6 or 0.5 air changes an hour. So you've got to make sure you get the air testing completed at the necessary stages. So once you've got your external shell up, you're watertight, all your windows and doors are in, and all your air tightness membranes are done, before you go on to any mechanical, electrical installations, air test. And we allow for 3 on our projects. Sometimes you may only need 2, but 3 is a belt and brace. The third one is generally at the end of the project. And we achieved, I think on air test 1 and 2 on this particular project, it was 0.7 on 1 and 2. But when we did air test 3, we actually went back up. We went over 1. And some of the things that could be missed are drainage pipes, not sealed correctly. Letterbox could be open. A window could be open. Real simple, basic things that will make your test throw up readings that you don't want to see. And so we've learned from this and created our own checklist now to make sure that everything's ticked before we do an air test. But on this last one, we actually did a smoke test. And then what a smoke test does, as you can see, you can't see anything, but what a smoke test does is you will then let off some smoke pellets around the building. You'll go outside and you will see where the smoke is coming from, which will aid you to find the problem. So if you've got a window open, you'll see it coming out. If you've got a cat flap open or a door slot open for your letterbox or whatever, you'll see it coming out. So it gives you a very clear visual aid of where it's coming from, so you can quickly go around and just activate some measures. But yes, it's a very important part of any retrofit or low energy project. So happy to answer any questions on an air test if anyone has any.
None in the chat yet. No.
Okay, excuse me. So as we move on, we will go into the M&E second fix. So we've gone through the dry lining phase. We're starting to come up, excuse me, onto the final hurdles. This particular one, we've got 3 sections: mechanical, MVHR, and electrical. So we'll show you some of the areas that we've been getting ready for. So underneath the stairs, coming back, every low energy passive house, EnerPHit project, and even projects that because we're having to move away from fossil fuels to heating property, commercially and domestically, air source heat pumps are a major requirement. But what people may not understand for an air source heat pump is there's a lot of gubbins that go with that internally, and so you need to have a space which is effectively a plant room for a cylinder, vessels, buffer vessels, all those sorts of things that allow an air source heat pump to work. And this is the under stairs area, so you can see it's like Mousetrap if anyone's familiar with the board game. You've got loads of different pipes going off in different directions all around the house. And so it's a well thought out process. And so with this, we have We're able to design air source heat pumps with our supply chain and do the installation. And so doing that very early on is an added bonus, because then you can work with your design team and your architects and just say, right, this is where we're going to put the air source heat pump, and this is where all the gubbins need to go. And so we need to bring all of this into here. And so you're planning the potential problems. Coming back to what I was mentioning earlier about the structure of a Victorian property, it doesn't work in the modern day. So we have to consider those multi steps ahead. So having on board someone that can design an air source heat pump is very, very important. And as you can see, there is a lot of pipe work to consider and also to be maintained as well. MVHR, so this is what all the ducts will look in certain areas of the project. So this is a back of house area. So this is actually in a storage area. You can see some of the plant work or the pipe work that you'll see. This is the MVHR unit. So this is actually accessed from a bedroom below. So you've got to consider how you maintain an MVHR. Installing it's one aspect. Future maintenance is also another aspect. So we've installed a loft hatch effectively below that MVHR. It has to drain as well. So this condensate pipe will take away any excess moisture into the toilet pipe work effectively and distribute that into the main sewer. And so you can see all these ducts, they are taking air in and out around the project. And so it always needs to be considered how you do that. And electrically, it's generally the same, in all honesty. You have to power all the plant, obviously, but from a perspective of a low energy, it's still electrical cabling. There's not a lot difference in all honesty. You've just got to have a good electrician on board to be able to work with your mechanical team to actually wire up an air source heat pump, solar PV, powering boosters, cylinders, underfloor heating. It all needs to just be thought about. So having on board a partner, builder, contractor that has that supply chain already there, familiar with this, will just be an added bonus to your project. So as you can see, we're getting up to the sort of finishing stages now. Lights are starting to come on as the project gets transformed. There you go. So you can see on the left-hand side, I'll just zoom in a bit more. You can see the size of the cylinder. We were restricted by space on this project. So a cylinder, they can, at this stage in time of an air source heat pump, they can only be vertical. We're seeing some talks about having some horizontal coffin style cylinders, but they're still very early stages. But as you can see on this particular one, that is a 2.5 meter tall cylinder. It had to be taller because it had to be narrower, so we had to fit it into this space. So all has to be considered when doing an air source heat pump installation. Electrical gubbins. So this is all the meter. So, this was prior to the air tightness strategies being implemented, but you've still got to consider all of the services coming into the building because they all need to be sealed. And so all of this becomes a challenge, a challenge that you can overcome with the right people on board. But you've got to consider, how do you maintain your electricity supply? You also need to consider, do we need to increase the supply? Because an air source heat pump actually requires quite a larger amount of power requirement than a traditional boiler. So you have to consider those things. You have to notify UKPN. So UKPN are the power network monopoly provider for the country. They have to be notified when you install a air source heat pump. You have to apply for a DNO, which is a certificate which allows you to ensure that they've done their calculation to ensure when you install an air source heat pump, there's no power outages. Because if everyone in your street all of a sudden put on an air source heat pump, there'd be blackouts. And so that's what they have to do. So there's quite a few steps that you've got to take to installing an air source heat pump, which is not advertised or, said in any sort of places, the government websites, all that sort of thing. You have to really do your exercise on this. So again, electrically, you have to consider what you're doing. That's about it on the M&E second fix. So if I've got any questions before I move on to the next section.
So not particularly on that section, I don't think. Callum asked, he had to very quickly leave to answer a call, but he was keen to know what the build up to the internal wall insulation to existing walls was.
Yeah.
And if the WUFI calculation was used. I don't know if that's whether you want to answer that now or at the end. It's up to you.
Um, different insulation levels to different walls, I'm afraid. So it wasn't completely straightforward. With the rear extension, which was made from the Larson Truss, it was 300 mil of dry therm insulation. So a very readily available insulation you can buy from B&Q, say. For the insulating lime plaster, it was 140 mil wood fiber. So that had to meet the specific U value of the requirement. Generally around 1.5, I think, is for a passive house retrofit. 1.4. The roof, slightly different. I think it was, again, I think we used a non-Kingspan board, but it was warm deck roof. So we had different strategies for different areas. So not a very straightforward answer, I'm afraid. But yes, different installations did have to be used to meet the requirements for the project.
Thank you.
On to the last hurdles, last couple of sections. So we've got the externals to give you, you saw some of the images earlier. So this is us starting to just strike the scaffolding. So you can see all the brick slips. This is the chimney, which had to be filled. So coming back to my points earlier in the discussion, the chimneys were down to be kept, but the problem with chimneys is they take smoke from inside to outside. So you've got an air passage. So these had to be deep filled with a small aggregate, which is also thermally insulating as well. They were completely filled. And so we had to redo all the haunches and new chimney pots in this instance. Just some of the lead flashing that we had to do to the neighbouring properties outside. And this was a flat roof, so everything's falling towards the rear. So the water's falling away into the guttering and then away. And then so and with all the fascia barge boards providing like a decorative feature. This is the view from on top looking down. So this is the front tiled elevation. So coming back to one of my original points, so we had a scaffolding completely over this entire property and the roof was completely rebuilt. That was down to the sheer fact that the original joists could not take the level of insulation that was needed, and they were also beyond repair. So it was a lot cheaper just to take it off and rebuild. As we go down, you'll see some of the images. Oh, sorry, apologize. This is from the rear elevation. So this was mid-flow of the project. So you can see the scaffolding outside giving us access to the rear of the property. Front elevation. So this was a new stone lintel, which we got sourced, procured, and manufactured for us. The original door frame was completely shot to pieces. London properties were Georgian, Victorian, Edwardian. They all have timber lintels internally. And so they need replacing. They just can't withstand any additional weight. So internally they were replaced, and so the outside one had to be replaced. It just wasn't in a very good condition. So you do have to consider external features. And come back to some of the points I made on the talk, our clients were very insistent that this looked like a traditional property. So we had to go and source the correct stone lintel. This is what it looks like now. We've got an externals package which we're doing this year. It was all down to budget, so the client went over budget during the build, and so we're having to revisit some of the works afterwards. But it just gives you an idea that it's no change from the outside. All the insulating properties, all the work was done inside, so aesthetically, it still looks the same. And we just have to be very mindful that we are seeing a lot of companies popping up, going around, just throwing up insulation on the outside of properties. And it's got a detrimental effect twofold, because what happens is we start losing these traditional Edwardian Georgian features, bay windows, stone lintels. You lose all these features, and we don't want to do that from a historical point of view. We're removing our history, but also we've also got to consider you can't just throw insulation up on the outside of the property. It has to be thought out, because the products they're putting on the outside, they're, in some cases, not all, but in some cases, they're effectively putting a plastic bag on the outside of a house and sweating it. And so they're just causing damage. So that's why you have to have the right design team, the right contractor, the right supply chain in place to make sure that these properties last for another however many 100 years. So this from the rear extension. So as you can see, we've now removed all of the scaffolding. Part of the external work packages that we're going back in for phase 4 is going to be stripping the paint and just doing some remedial works to the existing brickwork. This job finished on the last day before Christmas. So I think it was like the 23rd, 22nd. And so our aim was just to get our clients in because that was their driving factor. So that's why we're revisiting some of these external works at a later date. So just to go on, practical completion, handover clean. I think that is largely it, in all honesty. So I'm going to throw the questions out to the panel and see if I can answer any questions you may have.
Yeah, certainly. Thank you. That was really interesting, Carl, to see the process on a stage by stage basis. Carol asks, did you carry the internal insulation down the party wall, and what about the meters?
So what we did, let's see if I can help explain this a bit more. So we actually, because the meter position that you saw was not the original position. So the original position, if you came on the front door, it was actually up at a high level on the right-hand side. And we just raised it. It's going to be a major problem. And so we relocated it with the help of the power network and the client's energy provider. Relocated it. And so that position you saw, it was actually brought forward and it was insulated behind. And it met the insulation dry therm, met the lime plastering on the front elevation, all taped and sealed. And then we put some airtight boards behind the electrical meter. So all complied. And then we installed the cavity service battens and then some plywood patricing to fix the meter heads. So all of your income and services do need to be considered. And on this drawing, you can see around here, this circular section, this footing section here. You have to consider how your cables are coming in. And it's not just now, it's in the future. You've got to think about things like, am I having Sky TV or am I having Virgin or am I just going streaming? Or am I going to have an aerial? So all of these things got to come in. You have water coming in. Subject to how you're doing the project. If it's done in phases, you may still have to use a boiler. So you're going to have a gas pipe still coming in. By the time you get to the end, you won't have a gas pipe, but you've still got to consider all of these incoming services and making sure that they have correct grommets around the outside. So they usually come in a circular form. You tape around the pipe work and seal it back to the airtightness membrane. So, yep, I hope that answered your question.
So, conscious we are a little over time now, but I'll just ask a couple of what hopefully are quick questions. Ian asked earlier on, could you tell us the supplier manufacturer of the PH windows?
Yep, absolutely. So we have quite a wide supply chain for windows and doors now, but on this particular project, it was 21 degrees. They're based up in Huddersfield, got a very good name in the Passivhaus retrofit world, and they're very cost effective on in comparison to some of the other companies. Some of the other companies you can go to Internorm, 21 degrees, and Norsken. But 21 degrees generally come in a lot more cost effective than those two companies. But it's a project by project scenario, requirements, outcomes. And 21 degrees also sell all the thermal bridge mitigation compact foam, which goes with it. So you've got a one-stop shop for them as well. So, yep.
Cool. And Ian asked, what made you choose the ProPassive Smart Ply with tapes over existing brickwork between the chimney and the breast rather than something like Passive Purple?
Yes, we do use passive purple. It comes down to practicalities, because the passive purple, you can spray it onto the brickwork, but the brickwork has to be breathable. So it will stop the breathability of the existing brickwork. So you'll be stopping the moisture transfer. That's one aspect. Passive ply, in all honesty, my company is predominantly carpentry biased. So we're all carpenters predominantly, and it's just easy to work with sheet material. in all honesty, and you can see if there's airtight problems, if it hasn't been taped, if there's a damage. It's all about visibility. Passive purple, yes, you can see it, but it's how you install your services thereafter, because you've still got to fix your services to that wall if you don't have any internal lining. So it's project by project basis. Um, both products readily available. Both products got pros and cons. You've just got to weigh up what fits the best for your project, I'm afraid. So that would be, yep, speaking with your builder, architect, whoever it may be, and just risk assessing both elements of the work.
Thank you. I'm conscious we're really out of time now, so I'm just share this this final slide. But I just was interested to read out a final thought from Joaquin while this final slide is there. Joaquin just said, just to comment on heat pumps and grid capacity. If everyone had a heat pump in unimproved buildings, then yes, the grid wouldn't cope. If most have Passivhaus certified retrofitted homes, the grid could cope, likely even without using heat pumps, as the energy demand for heating would be tiny, far less than standard domestic appliances would use. And I was just quite interested in that, because I just wonder if you agree with that, actually, Carl, that if actually all homes were very energy efficient to high Passivhaus standards, then actually the heat pumps probably wouldn't need to be used that
Yeah,
much to that high level.
absolutely, very valid point, but they're not, and that's the reality.
Of
And
course, yeah.
the reality is, not everyone will want to do a passive house or a low energy or a retrofit. So your next door neighbor may not have that same purpose, same mission, same values as you. And we as a country are in a position where you don't have to do this. It's by choice. If we take Scotland as an example, they are a bit more mandatory about how you do new build volume housing or new build housing. It has to meet that standard. And that's where we've got sometimes it's a little bit of a political background, unfortunately. If all houses were up to the standard of retrofit, we'd be absolutely laughing. You're right, the demand will be there, but we're adding more infrastructure. So we're adding more to the infrastructure that's already there. And at the minute, we're probably all talking from a domestic point of view. That's not taken into consideration a commercial point of view. If you look at the demand of what hospitals, office blocks, all those types of commercial buildings, they've got a heavy demand on electricity. Then we've got data centers to throw into that. So it's a long upward journey that we've all got together. And we can only take it, one project at a time and making sure we're doing the best. But yeah, I totally agree. If all houses were to that standard, it would be plain sailing. But unfortunately, it's not. Apparently, the figures are we've got to retrofit 27 million homes. So there's a long way to go.
There is, there is. Um, Thank you, Carl, and thank you everyone who joined us today. That was a really fascinating um, uh, case study, and it was really interesting, like I say, to see each of those individual stages. So just to say again, thank you, Carl, and thank you to everybody
Yeah,
who has joined
absolutely.
us. There's a link there, or there's a QR code there to the Passivhaus Trust website, which has got all sorts of resources for homeowners or for Passivhaus architects and designers. So
Yeah,
thank you again, everyone.
yeah.
Today, we really appreciate everyone's time. Thank you so much.
Yeah, thank you, everyone. Really appreciate your time. If anyone has any questions, would like a bit more insight, anything, more than happy to answer some questions. And you can do that through our business website, company website, info@g2cnc.co.uk. Fire away. More than happy to sort of guide you down the right road, because we're on a mission to make sure that everyone is uh, getting educated and making sure we're doing better for the environment.
Thank you.